Hi class, Dr. Searcy here with the video lecture for Chapter 5, Odd Problems. Let's remember the title of the chapter is Z-scores, location of scores and standardized distributions. So let's go ahead and talk about problem 1 first. It says, what information is provided by the sign, positive or negative, of a Z-score? What information is provided by the numerical value of the Z-score? Okay, so they've got two questions in here. The first one is what we explained in the video lecture for the textbook. What does it mean when you have a Z that's either positive or negative? The answer to that is the sign tells you whether the location is above or below the mean. Let's just draw a curve real quick, right? Remember we were saying that Z-scores are now going to be these scores that are going to go underneath the curve. We've been talking about how there's the X values on the X-axis. There also is the mean, and the mean is always going to be right in the middle. And then below that is S and Z. Since S and Z basically map onto each other, I'm just going to go ahead and write down the Z row. And remember, what we're saying is, if you have a Z-score that is positive, then that means that it's going to be corresponding to some X value that's above the mean, or to the right on the number line. If you have a Z-score that's negative, on the other hand, then it's going to correspond to an X value that is below the mean or to the left of it on the number line. So then that second question was, what information is provided by the numerical value of the Z-score? Well, the numerical value tells the distance from the mean in terms of the number of standard deviations, right? So the idea is, as you move away from the mean, either in this direction or in that direction, you're going to start out with a Z value of 0, but then as you go out, it's going to be like a 1 or 2 or a 3. It's going to get higher the further out that you go. Just also remember that when you go in this direction, the Z's are going to be still getting higher as you move out, right? So 1, 2, 3, there's just going to be -1, -2, -3. Okay, so let's go ahead and move on to question number 3. Here it says, for a distribution with a standard deviation of 20, describe the location of each of the following Z-scores in terms of its position relative to the mean. And then they have this example here. A Z of 1 is a location that is 20 points above the mean. Okay, so all they're saying here is, again, you've got some curve, and they're telling you that the standard deviation is 20, right? So you've got your mean in the middle. But regardless, we don't even know what the X values are or what the mean is. All we know is that as we move away from the mean in either direction, the standard deviation unit, right, it starts out with 0 under the mean, but 1 here as we move away from the mean, and then 1 there as we move away from the mean. In terms of S, now remember the standard deviation units, they're not going to necessarily have any positive signs or negative signs. They're just going to have the number. What we're saying here is between the 0 and the 1, in terms of standard deviation units, there are 20 ticks in the center of that. Okay, so here then they're saying, let me reread the question. For a distribution with a standard deviation of 20, describe the location of each of the following Z-scores in terms of its positive or position relative to the mean. Okay, so here, if we have a Z of +2, right? So that's saying we're going at 20 and then another 20. So how far above the mean is that? It's above the mean by 40 points, right? It's 2 standard deviation units out, so a 20 there and then another 20 there. I put it so close just because I ran out of room. So then we have a Z of +0.5, right? So that's half of a standard deviation unit. If a standard deviation unit is 20 ticks, what's half of 20? Well, 10, right? So Z of 0.5 means that you're above the mean by 10 because the standard deviation is 20. So then, what if you have a Z of -1? Right, remember, so then that's going to be a Z here. That's going to be like a -1. How far did you go out? You went out 1 standard deviation unit, so you're going to have it be 20 points out. Why 20 points? Because that's how big a standard deviation unit is. So then, a Z of -0.25. So that's going to be like right here, right? Not too far away from the mean. So what would it be? What would the X value be up there? What's basically saying a quarter of a standard deviation unit. What's a quarter of 20? That's 5, right? Because 5 times 4 equals 20. Okay, so we've answered all the questions for 3. Let's go ahead and move on to question number 5. Here it says, for a population with a mean of 40 and standard deviation of 11, find the z-score for each of the following x values, right? So for each one of these x values, we're going to do a separate equation for each one of these. I know you probably will need to use a formula and a calculator to find these values. Well, I don't have the calculator for you, but I've got the formula. Remember, so the formula is z equals, and since we're talking about population data, it's going to equal x minus mu over the standard deviation. We've already been given mu, and we've been given the standard deviation, so it's going to be basically a bunch of z equals some x value minus that 40 over 11. Okay, so I've gone and figured those out for you here, and we'll just go through them one by one. First one is where we're given the x value of 45. That's going to be z equals 45 minus 40 over 11. First thing that we're going to do is a subtraction problem in the numerator. It gives us 5 over 11, so then it's just a division problem where the answer is 0.45. Moving on to the next equation. We were given a value of 52, so it's going to be z equals 52 minus 40 over 11. Again, we did the subtraction problem first. It gives us 12 over 11, which then gives us 1.09. So then the next equation is an x of 41 minus 40 over 11. 41 minus 40 is 1, so it's 1 over 11, gives us 0.09. From there, x value of 30 minus 40 over 11, so it's, here we have a negative 10, right, because 30 minus 40, so it's negative 10 over 11, gives us a negative 0.91. Then we've got x value of 25. Looks like it's going to be another negative value again because it's 25 minus 40. So it ends up being negative 15 divided by 11 gives us negative 1.36. So then we have an x value of 38. That's going to be 38 minus 40 gives you a negative 2 over 11, which then gives you negative 0.18. Okay, so that's it for problem number 5. Let's go ahead and move on to problem number 7. Here we're saying we've got a set of A problems and a set of B problems. But for both, we have a population where the mean is 60 and a standard deviation of 12. Just remember the equation again is z equals x minus mu over sigma, right? So in this case, it's going to be z equals whatever x value we've been given minus 60 over 12. Okay, so that at least this is our A set of equations. So then it's going to be, we've got an x value of 69 minus that 60 over 12. First thing we're doing again is just that knocking out of that numerator. So it's 9 over 12 gives us 0.75. So then x value of 84 means 84 minus 60 over 12. We end up with 24 over 12, which gives us 2. So then we have an x of 63. 63 minus 60 is 3 over 12, which reduces to 0.25. So then we had x value of 54 minus 60 over 12. Got a negative sign there because it's 54 minus 60. So negative 6 divided by 12 gives us negative 0.5. So then x value of 48 minus 60 over 12 gives us another negative 12, right? Because it's a negative problem there. So it's negative 12 over 12 gives us negative 1. So then we got an x value of 45 minus 60 over 12. We end up with negative 15 over 12, which gives us negative 1.25. Okay, so that's our solutions to all of our A problems. Now the thing that you want to notice is now we're going to have the same, let's see, for the same population, find the score that corresponds to each of the following scores. Okay, so we still have the same mu, and we still have the same standard deviation. But instead of giving us x, now they're giving us z, and we have to solve for x. So I've got that set of problems starting here. Okay, so our first problem is 0.50. It's going to go where the z goes. And the way so this is the original setup of the problem. The way I'm going to solve it is I'm going to, right, so your goal is to get that x by itself. The way I'm going to start getting the x by itself is I'm going to take this 12 out of this division problem. How I'm going to do it, I'm going to do it by multiplying it out of there. When I do, it cancels on that side, but then I have to multiply it by 12 on this side. That's how I get this 6, right? 0.5 times 12 is 6 equals x minus 60. I'm still trying to get the x by itself. So the way I'm going to do it now is I'm going to get that negative 60 out of there. How am I going to do it? Remember that we're doing algebra, and to get something out, I need to do the exact operation of what's currently going on. So I'm going to add it out because it's being subtracted. When I do that, they cancel. So I'm going to come over here, add it to that side. So it ends up being 66 equals x. Okay, so let's go ahead and move on to the next problem where the z is 1.50. So we start out again with z being 1.5 equals x minus 60 over 12. Right, remember the thing I'm going to do is first I'm going to move that 12 out. I'm going to multiply it on this side, then multiply it on that side. When I do, it gives me 18 equals x minus 60. Now I'm going to get that 60 out of there by adding it. The way I'm going to do that is add it to this side, add it to that side. When I do, I have 78 equals x. Okay, so then the next problem is negative 2.5. All right, just to make sure you see what I'm doing, I've got negative 2.5 in the z spot equals x minus 60 over 12. First thing I'm going to do is get rid of that 12. Right now it's part of a division problem, so I'm going to multiply it out of there. When I do, it cancels out on that side. I'm going to multiply it on this side. Negative 2.5 times 12 gives me 30. Negative 30. So then it's negative 3 equals x minus 60. I'm going to get that 60 out of there. How am I going to do it? Right now it's being subtracted, so I'm going to add it out. Cancels on that side. Add it over here. So that ends up meaning that 30 equals x. So then our next problem is negative 0.25. Right, so we've got negative 0.25 equals x minus 60 over 12. I'm going to get that 12 out of there, and then I'm going to put it over on this side. So now it's negative 0.25 times 12. What does that give me? That gives me, it gives me negative 3 equals x minus 60. So I'm going to get that 60 out of there by adding it. Add it over here. So now I have 57 equals x. Let's see. Now I have to move on to negative 0.50. So first thing I'm going to do is get that 12 out of there. Cancels on this side. Multiply it on this side. So 12 times negative 0.5, and it gives me negative 6 equals x minus 60. add that 60 out, and over here, so that gives me 54 equals x. So then the last problem for B is 1.25. Put it there. Gonna get that 12 out of there. Cancels on that side. Multiply it on that side, and that gives me 15 equals x minus 60. Add that 60 there. Cancel, cancel. Add the 60 there. Gives me 75 equals x. Okay, so that's everything for 7a and 7b. Now we're moving on to question number 9. Here it says, find the x value corresponding to z equals 0.25 for each of the following distributions. Totally forgot what I did here. Okay, find the x value corresponding to the z equals 0.25 for each of the... Okay, so obviously it's going to be where I have to think in terms of the equation. They gave me z, they also gave me mu, and they gave me the standard deviation. So what I'm looking for is the x. So the way I'm going to set the problem up to begin with is there's my 0.25, there's my 40, there's my 4. I'm solving for x. So the thing I'm going to do, I think it's just what I was doing over here. Sort of. Yeah. I'm first going to get rid of this 4. Right now it's part of a division problem, so I'm going to multiply it out. Bam, bam. What I do on one side, I've got to do it on this side. So times 4 on that side. So that gives me 1 equals x minus 40. Now I'm going to move that 40 out. How am I going to do it? I'm going to add it out because it's being subtracted right now. They cancel there. Add it there. And so 41 equals x. I also did this other thing too. You don't have to do this part, but I did want you to see how this corresponds to the curve. Right, so we have a curve here, and we're saying that we know x is 41, and at z is 0.25. So the way that we should write this out is, let's see, if mu is 40, right, because it's right there, and our standard deviation is 4, right, then we're saying 1 standard deviation unit away from mu is 44. However, we are at a z of 0.25. So really the question is, what x value corresponds to that 0.25? Well, it's an x value of 41. Okay, let's see how this works for the next set of problems. Problem B. There we're saying that now we still have a z of 0.25, but it's corresponding to a mu of 40 and a standard deviation of 8, right? So our standard deviation has grown from before. We're going to do the same thing, going to multiply the 8 out on both sides. That's going to give us 2 equals x minus 40. Now we're going to get that 40 out of there by adding it to both sides. And so that ends up giving us 42 equals x. Let's do the same thing. Let's see how it fits on a curve. We're saying our z is 0.25 and the x for that is 42. So the way things should work in terms of the curve is 40 is our mu, right? Because that's where it's saying it right there. Our standard deviation is 8. So moving out a standard deviation unit of 1 would be 48 on this side. Moving out a standard deviation of 1 on this side would be, let's see, 40 minus 8 is what, 32? But what we have here is a z of 0.25, right? So what corresponds, oh yeah, okay, not here because it's not a negative 0.25. It's over here because it's a positive 0.25. So what number is going to go on that tick? That 42 is going to go on that tick. Okay, moving on to problem C. Okay, so still have the 0.25 in the z spot. Our new mu is 40, but now our standard deviation is 16. So getting rid of that 16, cancels, times 16 on this side gives us 4 equals x minus 40. Going to get that 40 out of there by adding it to both sides. So then it means that we have a x of 44. So now, where is that 44 in relation to that 0.25? Right now, one thing that you should be seeing is as we move from problem to problem, our standard deviations are growing. Right? We started out with a standard deviation of 4, then it went to 8, now it's up to 16. Right? Right, and there it is right there. So a standard deviation unit of 1 would be, from 40 would be 56. Our question is, what is it for 0.25? Well, as we're seeing, it is now 44. So one other thing I hope that you're seeing is the z is always staying the same in all of these problems, right? It seems like, and even the mu is always staying the same in all these problems. The thing that's changing from problem to problem is the size of the standard deviation. And so what you should be seeing is, as the width of the standard deviation grows from problem to problem, right? Here was 4 units big, then 8 units big, then 16 units big. One thing you should be seeing is that what's happening with our x values, right? So let's see what happens with problem D then. D is saying we have our z of 0.25, our mu of 40, but now look at how big our standard deviation is. Now it's 32, right? So it's a big standard deviation unit. To solve, we're going to multiply both sides by 32 on that side, both sides by 32 on this side, and so it ends up giving us 8 equals x minus 40. Going to get rid of that 40 by adding it on this side. Cancel, plus 40. So now we have an x of 48. And so here now, whereas for a standard deviation unit of 1, the x that corresponds to that is 72. At the 0.25 mark, now our x value is 48. Right, so what we should be seeing here is when the standard deviation unit space was relatively small, right, only 4 units big, the x at 0.25 was relatively in the middle, right? It was at 41. But as we grow the size of our standard deviation unit from 4 to 8 to 16 to 32, it's interesting to see how the x that corresponds to 0.25 moves with that. Okay, so let's go ahead and move on to problem number 11. Here we're saying that the problem reads, a score that is 9 points above the mean corresponds to a z-score of 1.5. What is the population standard deviation? Okay, so this is a bit of a tricky question in the way that they're wording it. The tricky part is this score that's 9 points above the mean. What do they mean by that? Let's just think about the generic formula, right? So z equals x minus mu over the standard deviation. What they mean with this, a score that is 9 points above the mean, is they're talking about the difference between these two numbers. A score that is 9 points above the mean, right? We don't know what the actual two values are here, but we do know that the difference between the two values is plus 9. So the way that we're going to write the equation out then is like this. I already wrote the generic equation over here. But the way that we're going to write the equation out then is, this is basically saying that we've already solved that deviation part. And the solution to that deviation part is that we have positive 9. So the z equation then becomes 1.5 equals 9 over the standard deviation. From here, it's a matter of now solving for the standard deviation. So the way that we're going to do this is I'm going to isolate that standard deviation. And the way I'm going to do it, I'm going to move it around the way I've been moving denominators around in the previous problems. Right now, it's part of a division problem. So I'm going to move it from this side to the left side. And the way I'm going to move it is, since it's presently being divided, I'm going to multiply it out. When I do, they're both going to cancel on this side, but then just note that I'm now multiplying it on this side. So now the problem becomes, I think I wrote this twice, but now the problem becomes this. Right now it's standard deviation times 1.5 equals 9. Remember that the goal is to get that standard deviation by itself, so I'm going to move that 1.5 out. Right now it's part of a multiplication problem, so I'm going to divide it out. And when I do, it cancels on that side, and then I'm going to divide it on the other side too. So now it's standard deviation equals 9 divided by 1.50, and that gives us a standard deviation of 6. And that is the answer to your problem for that. Okay, so now we can go ahead and move on to number 13. 13 says, for a population with a mean of 70 and a score of 64, it corresponds to z of negative 1.5. What is the population standard deviation? Okay, so I'm just thinking here, what information have they given us? They told us what z was. They said it's negative 1.50. They told us what mu was, it's that 70, and they told us what this x was, they said it was 64. Right, so this is what we end up with. We are now solving for the standard deviation. This problem looks exactly like the same problem, so we're going to solve it exactly the same way. I want to isolate this standard deviation, but I'm going to do it by moving it to the left of the equal sign. Remember, the way that we did it was, because it's part of a division problem to begin with, we're going to engage in the opposite operation, which is multiplication. When we do that, cancels on this side, but then we're going to multiply it on this side. So now the problem becomes, darn it, I did it again. I rewrote this. I meant to do all of this here. Okay, but anyway, now that we've moved that standard deviation over, it's going to read like this, right? The standard deviation times the negative 1.5 equals the negative 6. At this point, I still want to isolate that standard deviation. I'm going to do it by moving this negative 1.5 out of here. Right now it's part of a multiplication problem, so I'm going to engage in the opposite operation. I'm going to divide it out. When I do, cancels on that side, but then I have to bring it over to the other side and do the exact same thing. So now it's 6 over that negative 1.50. That's what I just did here. So it equals 4. And so that is your standard deviation. Standard deviation is 4. From there, we have problem number 15. Oh my God, it looks big. Okay, so let's see what we got here. For each of the following populations, right? I guess each one of these is a population. Would a score of x equals 85 be considered a central score near the middle of the distribution, or an extreme score far out in the tail of the distribution? I suppose for this one, we need to kind of define what we mean by central and extreme. Here we're thinking in terms of that curve and the mean. Remember, right, so you've got that mean row, and then below it you've got that standard deviation row. Remember that your x bar is in the middle, and the value of your standard deviation is 0. And you're moving out some standard deviation units away from the mean after that, right? For instance, you've got this 1, so the 1 would go up there. Same thing on the other side. You'd have a 1 that would go up here. Okay, so here's what they mean by whether a x score is central or extreme. If the x value is found somewhere between the 0 and the 1, right? Either here or here, then that's saying that that x value is central. Why central? Because it's near the middle of the distribution. However, on the other hand, if you have some x value that's outside of that range, right? Say out here somewhere or out here somewhere, right? Then that's saying that it could be anywhere from the 1 all the way out in either direction. And that's where we're saying that then that x value is going to be extreme. It's going to be far out in the tail of the distribution, right? Remember, the tail is this part or that part, right? Basically that chunk or that chunk, right? And if the x value is somewhere in there, that's saying it's in the extreme, dude. Okay, so let's figure out for each one of these whether the x equals 85 is in the central part of the curve or in the tail part of the curve. First problem that we have is where x corresponds to a population mean of 75 and a standard deviation of 15. Let's see what I did to figure this out. Basically, I started off by just putting everything into a z equation, right? So the 85 goes there, the 75 goes there, and then the 15 goes there. From there, I just solved for the equation, solved for whatever z is. The way I did it was I first solved the subtraction problem in the numerator, gave me 10 over 15. So then I had a simple division problem that gave me now a z value of 0.67. Right, so now what you're thinking is, well, where does that 0.67 go under the curve? Right, so remember, z's correspond to s's. So that 0.67 is about, I'm going to put an A right there. It's about right here, right? 0.67. So it's within this area that we call central. Therefore, this score is central. Now let's look at problem B, where the mu is 80 and the standard deviation is 2. This time, the equation looks like this. 85 minus 80 over 2. Just going to solve for z here. Started off by just taking care of the subtraction problem. That gave me 5 over 2, which then reduced further to 2.5. Okay, so now we're saying we have a z of 2.5. Is that z within this 0 to 1 range? No. We're saying that that z is out further, like 2.5 is like over here somewhere. So we're saying then that z is extreme, dude, right? It's going to be over here somewhere. Okay, so what about C? For C, we're saying the 85 minus the 90 over the 20. First, going to solve for that subtraction problem. It's a negative 5 over 20, so that gives a z value of negative 0.25. Oh, this one I can track easily. The negative 0.25, that's about right there, right? There's our 0. We're going this way because it's a negative number. 0.25 is less than 1. So we're going to say because it's in the central region, that is going to be central. Okay, now this last problem, problem D, we're saying now the equation is 85 minus 93 over 3. That solves to negative 8 over 3, and that solves to negative 2.67. Right, so now we're saying, oh man, negative 2.67, that's over here somewhere. So because it's over here somewhere, it's in the extreme. Okay, so now let's go ahead and move on to number 17. Let's say this time the question reads, for each of the following, identify the exam score that should lead to the better grade. In each case, explain your answer. Okay, so basically what they're saying here is we have an A, B, and a C. In each of these problems, there are 2 scores, right? So for instance, for A, there is a score of x equals 70 on an exam with m equals 82. That's all 1 score there. Oh, and then they gave the standard deviation too. And then what we're supposed to do is compare that score to the second score in A, which is Aura's score of x equals 60 on an exam with a mean of 72 and a standard deviation of 12. Okay, so here's what we did. For each of these, in problem A, we calculated the z-score. Right, for the first one was that z equals 70 minus 82 over 8. 70 minus 82 over 8. For the second one, it's 60 minus 72 over 12. Okay, so for both of those, we have to solve for the z. I started off here by doing the subtraction. That gave me 70 minus 82 is negative 12 over 8. And then on this side, it's 60 minus 72, so that gave me negative 12 over 12. So for the first score, the z was negative 1.5. For the other score, it's a negative 1. Okay, now remember what we're doing here is for each one of these, we're trying to figure out which of these 2 is the better score, right? So you're thinking in terms of that curve. You got the mean. And let's just say all I want to plot this time is the z values. What we're seeing is that we have both of them being negative. The negative 1 would go there, and the negative 1.5 would go there. Right, so the question is, of these 2 scores, which one is the higher score? Well, the answer is that the negative 1 is higher because it's further to the right on the number line, right? It's the higher number. Both of these students did really bad on the test. They both got less than the average student's score on the test. But of the 2, the negative 1 student didn't do as bad as the negative 1.5 student, right? So that student got the higher score. Okay, so let's continue to use that logic with the next set of problems, beginning with B. I'm just going to go ahead and show you what I wrote down for B. Right, so I've got one z equation and then the other z equation. Where did I get the numbers for this first one? Well, that's at 58 minus 49 over 6. So then where did I get the values for this second z equation? Well, that's 85 minus 70 over 10. Now remember what we're doing here is this was one score on a test, this was another score on a test. We're looking to see which student did better, this student or this student. So we have to solve each student's z value. For the student on the left, we said 58 minus 49 is 9 over 6. And for the student on the right, 85 minus 70 gives you 15 over 10. So then each of these is a division problem that will give us a z. Student on the right got a 1.5, and the student on the left got a 1.5, and the student on the right got a 1.5. So what does that mean? Well, if we were to draw a curve, what we'd say is both of these students got the same spot on the z row. So the two students did exactly the same. Both were at that 1.5 spot. Oh, sorry. It's a positive 1.5, so it needs to be on this side. Both students got a z-score of 1.5, and so therefore they both did exactly the same as each other. Okay, so then that allows us to move on to problem number C. Where's C? Okay, so here is C. We're saying that we've got 32 minus 24 over 4. And then we also have 26 minus 20 over 2. So, got a couple of z's that we need to calculate here. First, we're going to solve each z. For the first one, in the numerator, I've got 32 minus 24. That gives me 8 over 4. And then in this numerator, I have 26 minus 20. So that gives me 6 divided by 2. Each of these solves to a z of 2 here and a z of 3 there. Right? So where does that put the two students on the number line? It says that this student got a 2 in terms of z-scores, and the other student got a 3 in terms of z-scores. Of the two students, right, the higher score is on this end, so the student got the 3, got the higher score. Okay, so that moves us on to problem number 19. Here it's saying, a distribution with a mean of 76 and a standard deviation of 12 is transformed into a standardized distribution with a mu of 100 and a standard deviation of 20. Find the new standardized score for each of the following values from the original population. Oh, so it looks like it's another z equation where we're just popping in different x's for each. But actually, what we're going to be doing here is two separate problems. I kind of explain why. Okay, so we say that we start off with a distribution with a mean of 76 and a standard deviation of 12. But like we said in lecture, then there's this transformation that happens. And basically a transformation is where you change the scores into a z-score. And once you've done that, you end up with this new mean and this new standard deviation. So how do we figure out what to do here? First thing that we have to do, right, so for problem A, is we have to take the information that we were given and figure out what is the z value given the first bit of information that they gave us. Right, so we're saying, I'm going to figure out z for an x value of 61. How am I going to do that? Well, they gave me the mean and they gave me the standard deviation. So once I do that, right, I'm saying that I'm going to solve it by saying 61 minus 76 is this 15, now over this 12. And that's going to further reduce to a z of negative 1.25. Now comes the part where we transform the data. Basically what we're going to do is we're going to take that z that we just got and we're going to transform it to where we have now a new standardized score. The way that we're going to do that is we're going to say that the z that we just got is now going to go into this new equation, right? Where it's now going to be z equals the new x that we're going to solve for minus this new mean and over this new standard deviation. So we're solving for x. First thing I'm going to do is get rid of that 20 in the denominator. Remember the way that I did it was I said that the 20 right now is part of a division problem, so I'm multiplying it out. So that gives me then 20 times negative 1.25 is negative 25 equals x minus 100. So now I'm going to get that x by itself by moving that negative 100 out. The way I'm going to do it is right now it's part of a subtraction problem. So I'm going to add it out. And that gives me then 75 equals x. So 75 is your new standardized score. Right, let's find the new standardized score for each of the following values. X is the new standardized score that you got because we've transformed it to conform to this new mean and this new standard deviation. Let's see how this works for problem B. Right, so remember this is a two-part problem. First we're going to figure out z, then we're going to figure out the standardized x value. So to begin with, figuring out z, taking my x of 70, subtracting 76 from it, and dividing that by the 12. First thing I'm going to do in figuring out z is the subtraction problem in the numerator. So it becomes -6/12, which then gives me a z of -0.5. Now I'm going to take that z, I'm going to transform it into a standardized x. The way I'm going to do it is I'm going to pop it into this new equation, where now it's that z value that I just figured out, that -0.5, equals x minus this 100 over this 20. So same thing as I did before. I'm solving now for this new x. I'm going to begin by getting rid of that 20. It's part of a division problem right now, so I'm going to multiply it out of there. They cancel, multiply it on the other side, and that gives me -10 equals x minus 100. So now I'm going to get rid of that 100. Right now it's part of a subtraction problem, so I'm going to add it out, cancels on that side, add it to the other side as well, and that gives me 90 equals x. So 90 is my new standardized score that represents the raw value of b equals 70, or x equals 70. Okay, so I have two more problems to go. One where I'm changing 85, right? So remember, I'm first taking that raw score of 85, finding out what its corresponding z value is, and then figuring out what its standardized x is. So the way that we do it is going to be 85 minus 76/12. That solves to 9/12, which then further reduces to 0.75. So I'm going to take my z that I just calculated of 0.75 and include it in my new equation. For now, it's 0.75 equals x minus 100/20. I'm going to start off by getting rid of that 20 by multiplying it out on both sides so that it becomes 15 equals x minus 100. I'm going to get rid of that 100 by adding it to both sides. Cancels out on this side, adds on this side, so now I have a new x value of 115. Last problem, problem D, where I start out with an x value of 94, right? So just to make sure that you guys are seeing this, first I'm going to transform it into a z, then I'm going to transform it into a standardized x. And that's where they're saying it. Find the new standardized score. Okay, so just going to circle that. So how am I going to do it? First, I'm going to figure out what the z for that 94 is. 94 minus 76/12 reduces to 18/12, but then solves for 1.5. So now my z of 1.5 goes into the equation, whereas that equals x minus 100/20. Going to get rid of that 20 by multiplying it by both sides. So then I get 30 equals x minus 100, which is going to get solved by saying adding that 100 out on both sides. So then I end up with 130 equals x. That's it. So that's how we do number 19. I'm going to go ahead and move on now to problem number 21. Here we're saying that we have a sample, right? So we're not talking about a population anymore. Now it's a sample. And it's going to have a mean of 30. Remember, Dr. Searcy calls that an x bar of 30. And a standard deviation, Dr. Searcy agrees that we use that lowercase s for standard deviation in sample. But it's 8, and so we're going to find the z-score for each of the following x values from this sample. Okay, at this point, I'm just reading stuff. I'm not thinking anymore. But I do know that I need to remember what the z equation is. So I'm just going to write it. It's z equals x minus sample mean over sample standard deviation. So the first problem is where I'm going to solve for x of 32, right? So it's going to be 32 minus 30 over 8. Where am I getting that 30? Getting it from there. Where am I getting that 8? I'm getting it from there. Find the z-score for each of the following x values from this sample. So I'm just going to start off by solving that subtraction problem in the numerator. Gives me 2 over 8, which then gives me a z value of 0.25. Okay, so then we can move on to x equals 34. That reduces to 34 minus 30 is 4 over 8. That gives me a z value of 0.5. From there, we have this x of 36. It's going to be minus 30 over 8. 36 minus 30 is 6. Divided by 8 is 0.75. So then I have an x value of 28 minus 30 over 8. It's going to be 28 minus 30 gives me negative 2 over 8. So the z here is 0.25. So then we have x value of 20 minus 30 over 8. 20 minus 30 is negative 10 over 8. So then we have a z of negative 1.25. So from there, then it is x of 18 minus 30 over 8. 18 minus 30 is negative 12, so that's negative 12 over 8. And that gives us a z of negative 1.5. Wow, that's all we had to do on that problem? So easy on that. Okay, so number 23, I accidentally moved problems into the wrong spot. So my 23 is at the bottom here. Let me go ahead and explain the answer by first reading the question, which says, for a sample with a standard deviation of 8, a score of 65 corresponds to a z of 1.5. What does the sample mean? Right, so again, this is the equation. We have a z equals x minus x bar over standard deviation. Looks like they gave us most of the numbers here, right? They said that z is 1.5, x is 65, and standard deviation is 8. So what we have to do here is solve for the mean. What is the mean? Remember that the first thing that we're going to do is, our goal is to get the x bar by itself on one side of the equation, on one side of the equal sign. So to isolate that x, I'm first going to move this 8 out. Right now it's part of a division problem, so I'm going to do the opposite operation. I'm going to multiply it out. When I do, it cancels on that side, but then I have to multiply it on this side, and so that gives me 12 equals 65 minus x. So now I've got this problem where if I move the 65 out, then I'm left with this negative x. So to avoid being left with the negative x, I'm going to move it out. Right, so I'm going to say add that negative x bar on this side, and then add the x bar on this side. So we end up with x bar plus 12 equals 65. From here now, I can engage in my my easy algebraic functions. I can just say I want to get rid of that 12. Right now it's part of a addition problem. So I'm going to subtract it out, cancels on that side, subtract it out on this side, and so that gives me an x bar of 53. Okay, so then that leads us to the last problem on the page, number 25. Here it says, in a sample distribution, x equals 56 corresponds to a z of 1, and x equals 47 corresponds to a z of negative 0.5. Find the mean and standard deviation for the sample. I think this is a situation that I talked about in the textbook lecture where it looks like they didn't really give us enough information to figure this out mathematically. So instead what we're going to do is we're going to see what it looks like for the equations, and then once we see that we can't solve the equations, we're going to try and figure out where the answer is on the graph. So let's talk about the equations first. We've got two sets of equations. First one is this one where it's saying I have an x value of 56 that corresponds to a z of 1, right? So all the information they gave for this one was where the x value was and what the z was. But they didn't tell us what the mean was, and they also didn't tell us what the standard deviation were. But they did say that this corresponds to another z equation where you have a x value of 47 that corresponds to a z-value of negative 0.5. Right, so we can't really solve either equation because we have two variables in each equation. So instead, I'm going to try and plot this information on a graph and see if I can figure out what my two means are and what my standard deviation is from looking at it on the graph. And that's where I have my graph here. So first thing I'm noting is my z-values on my graph. I have been given a z-value of 1, and I've been given a z-value of negative 0.5. And for each one of those, I've been told what the x is that corresponds to that, right? So I was told that for a z-value of 1, the x value that corresponds to it is 56. For the z-value of negative 0.5, the z-value that corresponds to it is 47. So now I can start to use this information to help me figure out what the mean is and also what the standard deviation is. First thing I'm going to do is I'm going to think about how many standard deviation units there are between the 56 and the 47. I'm noting that I've got a standard deviation unit here, and a standard deviation unit there, and a standard deviation unit there. How do I know all this? I know it because the 56 is one standard deviation unit away from the mean, and the 47 is half of a standard deviation unit away from the mean. So I know that if I'm organizing the data in this way, each of these units is a half of a standard deviation unit, right? Half of a standard deviation unit there, half of a standard deviation unit there, and half of a standard deviation unit there. From there, I'm thinking, okay, well, I've got this total distance between the 56 and the 47. And that total distance can be figured out through subtraction, right? I can say 56 minus the 47 gives me 16 minus 7 is 9. And then 5 minus 5 is 0. Okay, so that says that I have 9 spaces from the 56 to the 47. I also have 3 units within those 9 spaces. So at that point, now I'm thinking, what is 9 divided by 3? 9 divided by 3 is 3. So what that must mean is that each of these half of a standard deviation unit is 3. If half of a unit is 3, then one entire unit must be this 3 plus 3, which would be 6. Right? So I'm just going to lay out that logic there. It looks like my S equals 6. Right? Because one standard deviation unit from here to here is 6 ticks long. Half of a unit is 3 units long. Okay, so what does that mean then in terms of what the mean is? Right? The mean is going to be the value that's going to go right there. How am I going to figure that out? Well, I can do some math. I could say, okay, counting back this way, if I go down by 3 units, that 0.5 z value, the x value that corresponds to the z value of 0.5 must be 53. And then if I go down another 3 units to the z value of 0, that's going to be 50. So whereas my standard deviation is 6, my mean is 50. Okay, and I'll let you guys punch the numbers into these equations to see if all of that works. For now, I'm going to say I'm done with this chapter. Thank you very much.